we need to apply progressive tension increases to the muscle itself. This means we need to lift with good, consistent technique while using the acute training variables and progressive overload to push the level of intramuscular tension up over time. Also paying attention to things like the mind-muscle connection, at least on certain exercises, and eccentric control should also help, as those aspects of lifting have been shown to increase intramuscular tension. Okay, so we know that mechanical tension is the main thing driving muscle growth, but what happens next? How do we get from a mechanical stimulus like tension to a biochemical signal that commands the muscle to grow? Well, Dr. Tromelin explained this to me in terms of blocks of dominoes. He said that when one thing gets activated, it passes on the signal to the next thing, and so on. But if you're smart, you don't just build one chain of dominoes. You build out all these side chains so that they fall in a bunch of different directions. And it's the same thing with muscle growth. There isn't just one pathway with one outcome, but rather many different interconnected pathways with many different downstream effects. So with that in mind, let's start at the top. All right, so we lift a weight heavy enough that it creates active mechanical tension within the muscle. This is called the stimulus. The stimulus is sensed by mechanosensors, which sort of feel that the muscle is being pulled into tension and pass that signal on. Now, based on the latest research, it isn't perfectly clear exactly which molecules are doing this sensing, but the top candidates include costomeres, which are collections of proteins that sit in the muscle fiber membrane and are responsible for holding muscle fibers together and transferring force between muscle fibers during contraction. There's also titin, which, as a fun fact, is actually the largest protein we've ever discovered in humans, and because it runs parallel to the muscle fiber itself, could theoretically be responsible for sensing mechanical changes like stretching, but probably only at long muscle lengths. And then there's filamins, which bind to the famous actin proteins that slide during contraction, making them a really good candidate for sensing tension. And for the record, I read through the latest paper on all this sensing stuff from 2018, and I'll just say, this area of research is not well understood yet. To quote the authors directly, conclusively identifying major hypertrophy stimuli and their sensors is one of the big remaining questions in exercise physiology. Still, we can paint the rest of the picture with a broad brush for now. From the mechanosensors, a signal gets sent to a beast mode molecule called mTOR, which is a major regulator of cellular growth in general, not just in muscle tissue.